Good morning, dear students. My name is Krishnakishore.A and I am going to teach you complex numbers, and this is class number 5. In yesterday's class we completed exercise 1B. Now we are going to know some properties as well as some definitions of complex numbers. And yesterday we defined if z is equal to, so this is nothing but a distance from origin to that point, and we call this one as OP. And yesterday we draw that organed plane. So this is called origin, this is called as real axis, and this is called as imaginary axis. And this plane is named as organed plane. Now suppose P is the point in first quadrant. So P is x comma y. Then join OP. So the distance of the P from origin is denoted by R. And let's draw a perpendicular onto the real axis. And suppose this may touch this real axis at the point A. And suppose the angle made by the line OP with the x-axis in positive direction is theta. Then here this theta is called as amplitude or argument. Amplitude or argument. And that R is nothing but distance from origin to the point. According to the position of the point, that R may be extended up to infinity. And you can see this rotation is anti-clockwise, and we know that one rotation is equal to 2 pi radians, that is equal to 360 degrees. So generally we write 0 less than equal to theta less than equal to 360 degrees. And here, most importantly, when we are going to know about what is meant by amplitude or argument, so this is what the definition you must remember. The line OP bar making an angle theta with the real axis in anti-clockwise direction, or we can say in positive direction. So this theta is called as amplitude or argument. And here, as we discussed earlier, this may vary from 0 to 360 degrees, and most importantly the value of theta that belongs to minus pi comma pi is called principal value. Is called principal value. And of course, most importantly, this 2k pi plus theta also satisfies that one, and this is called as general value of the argument. So general value of the argument. And most importantly, you must remember when we are doing here, especially in complex numbers, the theta must lie in between minus pi to pi, and this is called as principal value. And everywhere we consider this principal value, and this general value always gives you a solution of the trigonometric functions. Okay, it's all enough. Then, so what is the use of this amplitude or argument? So that may be in our mind. Here we call one important form mod amplitude form or polar form. So polar form. So here, what is the meaning of that mod amplitude form or polar form, and how to convert the given complex number into that polar form or equivalently mod amplitude form? You can see here modulus, the word. So mappa means modulus. Modulus as well as amplitude. And already we discussed here, mod z is nothing but distance from origin. So we call here R is equal to mod z, that is equal to root of x square plus y square. And most importantly, theta is the angle made by that OP bar in the direction. Now look at the triangle from, let z is equal to x plus iy, as we consider here in the beginning. Z is equal to x plus iy. Now look at there, from triangle OAP, from triangle OAP, you can know in first year you are having the trigonometric functions. First of all, we define sin theta. So sin theta is equal to opposite side to theta by hypotenuse, and most importantly this is y and this is x. Sin theta is equal to y by r. Again by the same triangle, cos theta is equal to x by r. Now substituting from these, eliminating the values, so y is equal to r into sin theta, as well as x is equal to r into cos theta. So you call this one as equation 1. Now substituting these values in z is equal to x plus iy, we can notice that z is equal to, in the place of x right here, r cos theta plus I into r sin theta. So this implies z is equal to r into cos theta plus I sin theta. Now here, why we use this word mod amplitude form? So mod amplitude form, you can see here r is nothing but mod z, so modulus, and you can see here theta is the variable. According to theta, cos and sin will change. Now what happened here is, when z is expressed in the form of x comma y, now for these pair of real numbers there exists r comma theta. Now these coordinate points are replaced by 2, r as well as theta, and these are called as polar coordinates. Polar coordinates. That's why sometimes even this one is also named as polar form, because this theta as well as r both are called as polar coordinates. The polar coordinates are included here, that's why this is named as polar form. Or alternatively you can use this modulus as well as amplitude, both are included here, so we can call this one as mod amplitude form. And every complex number can be put into that form. Z is equal to r into cos theta plus I sin theta, and hence this is named as that one. Again you can see here from 1, so squaring on both sides, y square is equal to r square sin square theta, as well as x square is equal to r square cos square theta. Now adding these two equations, x square plus y square is equal to r square into sin square theta plus cos square theta, implies x square plus y square is equal to r square, and most importantly taking square root, therefore r is equal to root of x square plus y square, that is equal to mod z. Again by using those two relations we can see there from 1 sin theta is equal to y by r, cos theta is equal to x by r, and hence sin by cos tan theta is equal to y by r by x by r, that is equal to y by r. Therefore theta is equal to tan inverse of y by x, tan inverse of y by x. So this is the formula to find the argument or amplitude of the given complex number. And the most two important parameters, now they are having a connectivity with these x and y. The first one you can see r is equal to root of x square plus y square, that is equal to mod z. Now theta, to determine theta, theta is equal to tan inverse of y by x. So this is how to convert, and these are the two important steps to remember, how to convert a given complex number into that polar form or mod amplitude form, and most importantly every complex number can be placed in that form. Again, according to everyone in the polar form can be again bring back to that complex form. So this is the connection between these two. And the most important application is in the next forthcoming topics we are going to find the roots, maybe square root, cube root, fourth root, maybe nth roots. Then we can have much importance of these applications. So this is called as R. R is equal to mod z is equal to root of x square plus y square, and theta is equal to tan inverse of y by x, and always theta belongs to the interval minus pi comma pi. And here the complex number cos theta plus I sin theta is called as cis theta. The complex number cos theta plus I sin theta is simply denoted as cis theta. C stands for cos and I as well as that I, and S stands for sin theta. Cos theta plus I sin theta is equal to cis theta, and in the higher classes you can learn that this one is nothing but e power I theta. That is called as Euler's formula. Cos theta plus I sin theta is equal to cis theta, that is equal to e power I theta. Next one here, you can write here cis of minus theta. So cis of minus theta is equal to cos of minus theta plus I into sin of minus theta. Now cos of minus theta, cos is an even function, cos of minus theta is cos theta, and sin of minus theta is minus sin theta, so minus I into sin theta. So this is what? Cos theta plus I sin theta is equal to cis theta, which is equal to e power I theta, and here cis of minus theta is equal to cos of minus theta plus I into sin of minus theta. And here we are having some important discussions about this. So here the first one to discuss is if z1 is equal to x1 plus iy1 and z2 is equal to x2 plus iy2, and suppose z1 can be expressed in the form of r into cos theta 1 plus I sin theta 1, comma z2 is equal to cos theta 2 plus I sin theta 2. So most importantly r is equal to cis theta 1 r1 into, as well as z2 is equal to r2 into cis theta 2. Then we are having two important theorems. Actually the proofs are not necessary here. Now z1 into z2 is equal to r1 into r2 into cis of theta 1 plus theta 2. So here the product on the left hand side in terms of cis is distributed as sum, cis of theta 1 plus theta 2, and next one z1 by z2. z1 by z2 is equal to r1 by r2 into cis theta 1 minus theta 2. Again here the quotient, the division is distributed to the difference, and we can write this one as cis theta 1 minus theta 2, and these are all the two important points you must remember here, 2 as well as 3. And here comes another one. Now z is equal to x plus iy, z is equal to x plus iy, then z bar is equal to x minus iy. We know that z bar is nothing but conjugate of z. Now the conjugate of z can be obtained by changing the sign before that imaginary part. Now z bar is equal to x minus iy. Now here amplitude or argument, amplitude of z, so theta is equal to tan inverse y by x. So this is what the formula. Now let's observe here amplitude of z bar is equal to tan inverse of, you can see there, minus y, so minus y by x, and tan inverse of minus y by x is equal to minus tan inverse y by x and is equal to minus theta. So this is another point to be remembered. Point number 4. Z is equal to x plus iy, z bar is equal to x minus iy, then amplitude of z is equal to theta, then automatically amplitude of z bar is equal to minus theta. So the amplitudes differ by the negative sign. So immediately, if z1 is equal to x1 plus iy1 as well as z2 is equal to x2 plus iy2, then again argument or amplitude, argument of z1 into z2 is equal to argument of z1 plus argument of z2, as well as argument of z1 by z2 is equal to argument of z1 minus argument of z2. So these are all the properties, these are actually theorems. You could have the proofs of these theorems, but here proofs are not necessary, but the points are important, and as well as according to the modulus property here. So mod z1 by z2 is equal to mod z1 by mod z2, provided z2 is not equal to 0, as well as mod z1 into z2 is equal to mod z1 into mod z2. So these are the highlights of the points to be remembered. Again, see here. So this is what? The conversions of a complex number into mod amplitude form, or we can say that one as polar form, because for every ordered pair x comma y there exists another pair r comma theta which satisfies the same conditions, and hence r comma theta are called as polar coordinate. That's why this is also called as polar form, or we can use that word mod amplitude form. And here most importantly, cos theta plus I sin theta is simply written as cis theta. So cos theta plus I sin theta and is equal to e power I theta, which is called as Euler's formula. As a case, cis of minus theta. So here in the place of theta is replaced with minus theta. Cis of minus theta is equal to, according to this, cos of minus theta plus I into sin of minus theta. That is equal to cos theta minus I sin theta. Next, importantly, suppose z1 is equal to x1 plus iy1, z2 is equal to x2 plus iy2 are complex numbers, and these are their polar forms. Z1 is equal to r1 into cis theta 1, cis theta 1, z2 is equal to r2 into cis theta 2, then z1 into z2, the operation on the left hand side is dot between these two complex numbers. On the right hand side you can observe r1 r2 to cis theta 1 into cis theta 2, which will become as cis theta 1 plus theta 2. So multiplication has transformed to addition, and here z1 by z2, the division, is equal to again r1 by r2 into cis theta 1 by cis theta 2, and you can see here cis theta 1 minus theta 2, or you can see here 1 by cis theta. 1 by cis theta is equal to 1 by cos theta plus I sin theta, and rationalizing here we can have cos theta minus I sin theta by cos theta minus I sin theta, and again 1 into cos theta minus I sin theta is equal to cos theta minus I sin theta. Most importantly, in the denominator, a plus ib into a minus ib is equal to a square plus b square. We can have 1 in the denominator, and cos theta minus I sin theta is nothing but cis of minus theta. So this is what 1 by cis theta is equal to cis of minus theta. Next comes the most important second part. Up to now here we are discussing about polar forms. Now it came there. If come here, see amplitude of z is theta, then theta is given by the formula tan inverse y by x, and z bar, the conjugate of z, is equal to x minus iy. So amplitude of z bar is equal to tan inverse of minus y by x and is equal to minus tan inverse y by x, that is equal to minus theta. So what to remember is a complex number and it's a conjugate, their amplitudes differ with negative sign. A complex number and its conjugate differ with the negative sign. Next comes here z1 is equal to x1 plus iy1 and z2 is equal to x2 plus i2. Then argument of z1 into z2 is equal to argument of z1 plus argument of z2, much is similar to this one. Again, argument of z1 by z2 is equal to argument of z1 minus argument of z2. And here yesterday we got already modulus, and mod of z1 by z2 is equal to mod z1 by mod z2, and mod z1 into z2 is equal to mod z1 into mod z2. And here most importantly, you must remember always mod z is always greater than or equal to 0, and it will be 0 if both x and y are 0. Otherwise mod is nothing but, you can understand, distance, and distance never be negative. It may be 0 if it is origin, otherwise it is always positive. So these are the points to be remembered in this class. In addition to this one, when we are converting into polar form, so many will have a confusion here, because the principal value of theta lies in between minus pi and plus pi, minus 180 to plus 180. But we can have the 4 quadrants there. In the total 4 quadrants, the angle will be 360 degrees. The 4 quadrants are called as quadrant 1, quadrant 2, quadrant 3, quadrant 4. And in quadrant 1, sine and cos are positive. In quadrant 2, sine is positive, cos is negative. In third quadrant, sine and cos are both are negative. But here the principal value of theta lies in between minus pi and pi. We know that in third quadrant the angle is more than 180 as well as less than 270. So we don't take the principal value in third quadrant. Similarly, the last case, suppose cos is positive, sine is negative. Cos is positive, sine is negative. Then what will happen is we will move to fourth quadrant. In fourth quadrant the angle will be 270 plus theta or 360 minus theta. Again that value does not belong to this one. Then what are the adjustments to be done when we are doing the conversion of complex numbers into the polar form or mod amplitude form? So here, so note z is equal to r into cos theta plus I sin theta, comma theta belongs to minus pi comma pi. Now here in deciding r, it's very simple. R is equal to root of x square plus y square. But here according to the signs of cos and sine, we have to choose the values of theta so that it will become the principal argument. Now let's see. So first point, cos is positive greater than 0 as well as sine is positive. So take theta in first quadrant. Take theta in first quadrant because we know that every trigonometric function is positive in first quadrant. And comes second one, cos is negative and sine is positive, and take theta in quadrant 2. So here comes a little confusion. So this is what third one, cos is less than 0 as well as sine is less than 0. Then what will happen here? Take theta as minus of pi minus theta. So minus of pi minus theta, and clearly pi minus theta is belongs to this one. The minus of pi minus theta lies here. So especially in this case both cos and sine are negative. You cannot go to third quadrant. You must remember that the principal value must lie in between minus pi and pi. So this is what you must remember in this case. And last one, fourth one, cos is positive and most importantly sine is negative. So replace theta with minus theta. So in the place of theta you write minus theta, because cos of minus theta is cos theta, sine of minus theta is minus sine theta. So all the four conditions you got here, and clearly minus theta lies in this interval minus pi to pi. So these are the two important points to be remembered, especially we are doing that mod amplitude form. We cannot take the value of theta in third quadrant as well as fourth quadrant, but in first quadrant it is as usual, in second quadrant also it is as usual. Most importantly to notice is here both cos and sine are negative. Then take theta as minus of pi minus theta, or somebody will write minus pi plus theta, no problem. And the last one, cos is positive, sine is negative, then replace theta with minus theta. So note 1. Here comes another one, note 2. Suppose z is equal to sine theta plus I into cos theta, or we can write z is equal to r into sine theta plus cos theta. And most importantly, every student must understand that polar form is always of the form cos theta plus I sin theta, that is equal to cis theta. So real part is associated with cos and imaginary part is associated with sine. But you observe here, this is not in standard form. This is of the form z is equal to r into sine theta plus I cos theta. A simple conversion we will do here by writing the quadrant angles. Now sine theta can be expressed as cos 90 minus theta plus I into sine 90 minus theta. So this is nothing but this is equal to r into cis pi by 2 minus theta. So this is also another important one to notice. However it may be, when you are saying that mod amplitude form or polar form, it is always of the form z is equal to r into cos theta plus I sin theta, and theta belongs to that minus pi comma pi. And most importantly, suppose the given complex number is of the form z is equal to r into sin theta plus I cos theta. Now this can be done a small conversion to write this one in that polar form. R into sin theta is cos 90 minus theta plus I into sin pi by 2 minus theta. This is equal to r into cis pi by 2 minus theta. Now before going to that exercise C, just we will consider one or two examples. Suppose we take example 1. So z is equal to 1. Then how can we write 1 in polar form? Polar form means r into cos theta plus I sin theta. And we know that 90, cos 90 is 0 and here sin 90 is 1. Now we can write z is equal to 1, that is equal to 1 plus I into 0. z is equal to 1. Write this one, this is real number. Express this one in the form of a plus ib by taking imaginary part as 0. So 1 plus I into 0. 1 plus I into 0 is equal to 1. Now write this one as z is equal to, so 1. So now compare here, cos theta is equal to 1. Cos theta is equal to 1 means theta is equal to pi by 2. And cos theta is equal to 1 means theta is equal to 0 degrees, and sin theta is equal to 0. Now write this one, so cos 0 plus I sin 0. So cos 0 plus I sin 0 is equal to cis 0. You can write a small degrees to remove your confusion. So z is equal to 1 and 1 is equal to cos 0 plus I sin 0. Now z is equal to minus 1. So write this one as minus 1 plus I into 0 again. There is no imaginary part in that given number. Then minus 1 plus I into 0, cos pi is minus 1. So write here cos pi plus I sin pi, and cos pi plus I sin pi is equal to cis pi. And here comes the next one. Z is equal to I. Now this I can be expressed as there is no real part in I. So write that one as 0 plus I into 1. Now by comparing this one, in the place of cos theta you can have 0. In the place of sin theta there is 1. And cos theta is equal to 0 for theta is equal to pi by 2. And sin theta is equal to 1 for theta is equal to pi by 2. Now write this one as z is equal to cos pi by 2 plus I sin pi by 2. Cos pi by 2 plus I sin pi by 2. And this is equal to cis pi by 2. So cos 90 plus I sin 90. Cos 90 is 0, sin 90 is 1. Next comes z is equal to minus I. Again write this one as 0 plus I into minus 1. Again real part is 0 here, and you can see sign is negative. Now write this one as cos of minus pi by 2 plus I into sin of minus pi by 2. Now cos of minus theta is cos theta, cos 90 is 0, sin of minus theta is minus sin theta, and sin 90 is 1. You can have, so cis of minus pi by 2. So dear students, so these are the highlights of this class, and most importantly how to convert a given complex number into mod amplitude form or polar form. And you must remember this one, z is equal to r into cos theta plus I sin theta, where r is nothing but mod z, that is equal to root x square plus y square. And these are the 4 important points the students must notice. And here cos is positive, sin is positive, take the value of theta in first quadrant. And here cos is negative, sin is positive, as usually go with the second quadrant. And most importantly, these are the flower brackets. You can see cos is negative, sin is negative, then take theta as minus of pi minus theta, because we cannot take the value in third quadrant. Similarly, cos is positive, sin is negative, then replace theta with minus theta, so that all these are the principal arguments. So we can say principal arguments which clearly belongs to that interval minus pi comma pi. And next one, if z is equal to r into sin theta plus I cos theta, this is not in standard form. Now write this one, cos pi by 2 minus theta plus I sin into pi by 2 minus theta, and these are what so these are called fourth root of unity. The first one is 1 is equal to cis 0, and second one is minus 1, that is equal to cis pi, and next one is I, that is equal to cis pi by 2. Next one is equal to minus I, that is equal to cis of minus pi by 2. So in the next class we will go to that exercise C, and we will do some problems on conversions into polar form as well as the properties of modulus, and maybe some problems on argument. Okay, thank you.